Celtra is a high-strength, zirconia-reinforced silicate glass ceramic material. With its exceptional microstructure, Celtra offers both optical and mechanical advantages. High strength and edge stability, quick and easy polishing, and natural opalescence. These are only a few of the benefits that dentists and dental laboratories can now enjoy when fabricating and delivering highly aesthetic restorations. Both a CAD and a pressing version of the material are available, Celtra Duo and Celtra Press, respectively. This user training will discuss the various steps involved in processing Celtra Press and its system components. Initial clinical situation. A 49-year-old female patient wanted a new restoration in the upper right quadrant. Both molars were restored with extensive fillings. The two premolars with metal ceramic crowns. Above all, the patient was uncomfortable with the exposed metal rims of the metal ceramic restorations. The zirconia-reinforced high-strength lithium silicate ceramic Celtra Press was the material of choice for the new monolithic crowns. In addition to a stability of more than 500 megapascal, this high-strength glass ceramic offers high translucency and a pronounced chameleon effect, resulting in aesthetically appealing restorations with the staining technique. First, the two premolar crowns were separated and removed. The stumps showed intensive discolorations that impeded an all-ceramic restoration. Therefore, the old amalgam buildups were removed and replaced by tooth-colored dentine adhesive-retained composite buildups. The molars and premolars were prepared with a circular chamfer and a cutting depth of approximately 1 millimeter. In the occlusal region, a minimum removal of 1 millimeter was intended. A comparatively small preparation angle created a retentive preparation. Prior to impression taking, the color of the new restoration was determined. The adjacent natural teeth served as a reference. In this case, the basic color was determined as A2. Choosing the optimum color and translucency of the pressable material is essential for the aesthetic success of the restoration. Therefore, the dental lab needs exact and comprehensive information on the stump color. Impressions of the prepared teeth were taken with Aquacil Ultra Monophase and Aquacil XLV in the double mix technique.
We'll be using a clinical case to demonstrate the restoration of a molar with Celtra Press, guiding you through the procedure one step at a time. There are two techniques that can be used for wax-up. The first one is the classic. Here, the crown is backstopped individually. For this, we use varnished dies. The varnish serves as a placeholder for the cement layer. To check the marginal fit, the preparation line must be drawn on the die. The second technique uses CAD/CAM technology. For a virtual wax-up, the dental stone that the die is made of must be suitable for optical scanning. The dies are now scanned, the data saved. In this technique, no varnish is used and no preparation line is drawn on the dies. The software takes the space required for the cement into account. A hand-drawn preparation line would distort the result. The virtual wax-up of the crown is now produced using the appropriate software, and the crown is then milled in wax. In either technique, at this point, the wax-up is checked for fit, marginal adaptation, and contacts. We can now proceed to the spruing step. For spruing, we use our Celtra Press muffle base. The choice of a 100 or 200 gram muffle is dictated by the number and size of objects. In this case, the 100 gram muffle is the right choice. We recommend the use of spruing and modeling waxes developed specifically for pressable ceramics. The sprue for a single crown will have a diameter of 3.5 millimeters. In the case of bridges, we use a piece of pressing wax wire with a diameter of 4 millimeters. The height of the sprue and object combined must not exceed a total of 16 millimeters. The object or objects must be placed halfway between the muffle wall and the center of the muffle. The pressing channel is waxed onto the contoured crown in the direction of flow. Make sure that the diameter of the pressing channel does not taper off where it is attached to the object. To make sure we remember the exact position of a crown, we place an appropriate mark at the muffle base. This will facilitate and accelerate the subsequent divesting step. We now place the investment ring on the muffle and recheck the position of our object. The crown is now ready for investing. For investing, we use the specially developed Celtropress investment. It has a finely structured and homogeneous surface and prevents the formation of a reaction layer. This eliminates the additional acid washing and sandblasting step. Consult the directions for use for the recommended concentration for the specific indication. The mixed investment is poured into the muffle using gentle vibration. We apply the ring gauge to ensure that the muffle is positioned at a right angle. After a setting time of 20 minutes from the start of mixing, we remove the ring gauge, muffle base, and investment ring. Using the speed process, we now place the muffle on a honeycomb sagger tray in the furnace at 850 degrees Celsius. Do not preheat the investment plunger and pellets. After 45 minutes, the 100-gram muffle can be pressed. In the present case, we selected the Celtropress MT-A2 pellet on the basis of the selected tooth shade. The pressing furnace should already be preheated to the corresponding base temperature. We now start the appropriate pressing program. For best results, we recommend regular calibration of the pressing furnace. Once the pressing furnace has reached the starting temperature of 700 degrees Celsius, we place the entire assembly in the furnace and start the program. On completion of the pressing procedure, the muffle is removed, placed on a heat-proof surface, and allowed to cool to room temperature. Only a few steps are needed for quick and safe divesting. The mark we placed at the muffle base indicates the exact position of the object within the muffle. Holding a plunger next to the muffle, we mark the object's approximate length. The muffle is then segmented with an appropriate cutting wheel, and the segment containing the object is removed. The next step consists of divesting with 50 micrometer polishing beads at a pressure level of 3 bar, which is reduced to 2 bar once the object becomes visible. Alternatively, divesting can be done with alumina at a maximum pressure of 2.5 bar. The sprue is cut with a diamond separating disc. Any sprue residue is then removed with the diamond polisher. No high-speed handpiece and no irrigation are required. The pressed crown is placed on the die to check its fit. The crown margins and contact points are checked and adjusted as needed. To achieve a uniform surface for staining, we smooth the restoration with silicone rubber cups and tips. This allows the stain to be applied evenly over a large area. This also prevents puddling. The crown is now ready for monolithic staining. For a realistic reproduction, we use the shade of dye specified by the dentist. In this case, we thus produce a dye in A2 resin. We isolate the crown following the pertinent recommendations and introduce the selected dye material. A retaining pin is inserted and then cured with a polymerizing lamp. The crown is now ready for staining. First, however, it has to be coated with a thin glaze layer. Now we can apply the stain at the desired locations so as to achieve the most natural results. We now remove the dye and place our crown on the firing tray as recommended. A special feature is the power firing step. Power firing increases the strength of the Celtropress restoration to more than 500 megapascal. For monolithic restorations, this step is already included in the glaze and stain firing cycle. After complete cooling, the shade is checked. Any correction to the shade that may still be necessary can now be performed. Note that the firing parameters are different for correction firings. In more aesthetically demanding cases, a prior preliminary try-in can be helpful. If the cutback technique is used, the power firing step must be performed before applying the first ceramic layer. Celtroceram offers a wide range of materials for the veneering and cutback techniques. Opal incisal and effects assist the production of aesthetic restorations. We'll use the cutback technique as an example to show how quickly and easily this goal can be achieved. The basis for the cutback technique is a framework with a reduced anatomic contour. Structures such as mamelons are created at this stage. Various incisals and opals are used for the veneer to achieve a variety of optical effects. With Celtropress and Celtroceram, you can achieve brilliant results in a minimum of time. The restorations are now ready for delivery.
The finished crowns are now ready for try-on. Due to the high strength of Celtropress, the occlusal contacts can be checked without cementation. If minor corrections should be necessary, fine grid diamond instruments are the first tool of choice. Diamond impregnated polishing instruments made of silicone or polyurethane are suitable for a safe and easy mirror finishing of the grinded areas. Additional glazing is not necessary. Restorations made of zirconia-reinforced lithium silicate ceramics should preferably be cemented adhesively. Both dual cements with a separate bonding as well as self-adhesive cements are appropriate. Self-adhesive cements are the material of choice if the preparation design guarantees sufficient retention. This mainly applies for full crowns. First of all, it is necessary to condition the restoration with 5 to 10% hydrofluoric acid for 30 seconds. The resulting micro-retentive surface offers optimum preconditions for a bonding with the fixation material of choice. In the next step, a silane material is applied to the etched inner surfaces of the crowns. It serves as an adhesive. After an exposure time of 60 seconds, a safe bonding with a composite cement is achieved. The self-adhesive cement is now directly applied to the crowns. The crowns are now inserted and their correct placement is verified. After the correct positioning of the crowns has been checked, Cement residues are pre-cured for 5 seconds, each in the vestibular and palatal labial areas. This initial curing process guarantees a safe fixation of the restorations. Excess cement can now easily be removed with a probe. After all excess fixation materials have been removed, each restoration should be light cured for 40 seconds. If necessary, minor corrections can be performed with fine grid diamond instruments and diamond impregnated silicone, respectively polyurethane polishing instruments. For several years, ZLS ceramics have been established as a new material class, especially for the fabrication of CAD/CAM produced restorations. The unique combination of high stability, superior optical properties, and easy polishing is extremely convenient. Celtrapress now offers the benefits of all these positive properties even in conventional processing.